ฮัลโหลให้กันบ้านข้อนี้ทำเป็น เฉลยไปหรือยังเอ่ย
ยังนะครับ
ยังไม่ได้เฉลยนะ Okay, in the previous lecture I assigned you some question, okay, some exercise, okay, that you do by yourself or yeah. Okay, the key of this question is how to model xc, how to write xc in the mathematical function form. Okay, in this case, okay, is determine the Fourier transform of this signal. For this case, this signal is already periodic. Therefore, you must apply periodic formula. Okay. Therefore, in order to determine the Fourier transform of the periodic signal from the definition, you must determine the Fourier series first. And the Fourier series AK of the continuous time periodic signal can be given by here. This one period equal to 2, right? This period equal to 2. Okay, therefore you substitute 2 in here. Okay, therefore you get omega naught equal to pi. Okay, after that you will determine AK in one period. In this case, when you integrate AK, you separate in two zones. The first one starting from 0 to 1, and the next one starting from 1 to 2. From 0 to 1, okay, xt, you can write them in terms of 2t. Very simple one, okay. And the others, okay, for the second region is 0. Okay, you integrate 0, give you 0. Therefore, in this case, the AK will be is only 2t. Okay, you substitute them, integrate them. Okay, in this case, it's required by Pascal. Okay, TEAT, integrate TEAT, give you distribute in here and here, step by step. And after you integrate them completely, you substitute the range of them between 0 and 1. You can see that 0 and 1. Okay, okay, 0 to 1. Okay, 0, 1. Okay, now after you get here, this is the closed form of the AK. Okay, it's not finished yet. Okay, why? Because the questions don't ask you for the Fourier series of them. It's ask you for the Fourier transform. But the Fourier transform of the periodic signal must use the Fourier series coefficient to compute it. From the definition, the Fourier transform of a continuous time periodic function is given by here x j omega, okay, equal to summation starting from k from infinity to infinity, 2 pi ak. Delta omega minus k omega naught. In this case, omega naught equal to pi because t naught equal to 2, okay? And after that, you substitute ak from the thing that you compute in the previous step, give you here. This is about the Fourier transform of periodic signal. Okay, the next one, using the Fourier transform definition to determine the Fourier transform of this signal shown in this figure. Okay, in this case, the graph will be in the sinusoidal waveform, but in this case, it will be cos function. But the cos is only, okay, 1/4 period. Okay, it's only one. Okay, even though the period of them is, okay, even though the period of them is about 2, okay, the period of them is 4. Okay, by measuring, okay, is equal to 4. You may, in this case, it integrate from -2 to 2. Okay, you can see that, okay, we separate them in 3 zones. The first one is 0. Okay, from -2 to -1 is 0. Okay, and from 0 to 2 is a 0, 2. It's only between -1 to 0, it will be the cos function. Is cos only? No. You must model the graph to matching to the xt function. In this case, the maximum of cos is 1, but in this case, the cos is 2. Therefore, you must normalize them. Use the, okay, amplitude scaling, okay, by 2, and, okay, the period of them, omega, substitute them, okay, give you pi by 2 t in here. In this case, it gives you cos t EAT, required by Pascal, okay. Okay, from the bypass integration definition, you can see that integrate EAT cos B theta give you here in the closed form. Okay, Therefore, the above equation can be expressed by this form. Okay, substitute them. Okay, A equal to minus jk pi t by 2. Okay, is A in here, S is in here, S is in here. Okay, for the B is here, B equal to 0.5 pi or pi by 2. Okay, after you substitute them formula completely, don't forget to substitute the rank of them. The rank starting from minus 1 to 0. Okay, sine 0 give you 0. Okay, cos 1 or minus 1 give you 0 too. Okay, therefore, you can simplify them to be here. Organize the term. Okay, here, finish. Okay, from this, I think you will maybe have some idea to determine them. Okay, and in this case, it finished only for the Fourier series. Okay, but the questions don't ask you for the Fourier series. It asks you for Fourier transform. Okay, using the Fourier transform definition equation, determine the Fourier transform of the signal shown in the following here. Okay, you get here. Okay, you get AK, substitute them from the definition. Fourier transform of this will be equal to Fourier series will be push them in this form. Okay, the summation k starting from infinity to infinity. 2 pi AK, delta omega minus k omega naught. Omega naught is, you can determine omega naught by substitute t equal to 4. Therefore, omega naught equal to pi by 2. Okay, AK equal to this term. Okay, substitute them. Okay, here is the final answer for, is a form of the Fourier transform for this periodic signal. Okay. Next one. Okay, now in the first section, we teach you about the Fourier transform for a periodic signal. The second one, I teach you the Fourier transform for periodic. Now, you know that the Fourier transform is already unified framework that can apply on periodic and aperiodic. Okay, the more things in here is discuss about the property of the Fourier transform. This section will present this numerous property of the Fourier transform. The Fourier transform have the several properties which make the Fourier transform an extremely valuable mathematical tool in the study of the continuous time signal and system. It will be convenient to define the notation similar to that used in the Fourier transform to indicate the pair of the signal and its transform. Okay. Xt, okay, the Fourier transform of them is x omega, or you write them in the form of the Fourier transform of xt. Okay, and the inverse of them, the Fourier transform is xj omega. The inverse of them, f minus 1. Okay, xj omega equal to xt. Therefore, in this case, you can conclude that xt and xj omega is the Fourier transform pair. Okay, the property, they have several property, and the property can facilitate the problem. Okay, the first one is here, xt, if the Fourier transform the xt, the signal xt is x1 omega. The Fourier transform of x2t is x2 omega. The Fourier transform of the sum of x1t and x2t equal to x1 j omega plus x2 j omega. You multiply the constant, can be multiplied by a and b constantly. Due to the linearity property, there is readily extend to the linear combination of the arbitrary number of the signal. Okay, how to take advantage of the linearity? The linearity is one of the most powerful property of the Fourier transform to make us analyze the complex signal. Okay, if you have a very complex signal, instead you analyze them in the single piece. No, you maybe separate them in each piece. For example, separate them in x1, x2, x3, for example. You maybe separate them into the even part and the odd part. Okay, and you determine the Fourier transform of the even part first and the odd part later. Okay, the Fourier transform of the original signal equal to the sum of the Fourier transform of this result. Or in the real telecom, the modern telecom engineering, okay, for example, the ultra wideband. Instead, we analyze the signal, the whole range in the very wideband signal, that very difficult. No, we can separate them into maybe 10 or 100 or 1,000. Okay, each band is only a very small on the narrow band. Okay, but we combine every narrow band together, you get outer wideband. Okay, the high speed. Okay, the wider bands communication is, the faster in the communication is. Okay, this is the replication of them. Okay, now in this idea, the Fourier transform of this property determine the Fourier transform of this signal. For this signal, you can determine the Fourier transform directly, but okay, you must integrate them, separate them into the phi zone. Okay, 0, phi, 10, and phi, and 0 again. Okay, no, if you use an alternative technique, okay, you split this graph by to be, okay, you split the complex graph to be the two simple graph. Okay, two simple rectangle. You can see that you add them, give you here. Okay, x1 and x2 is very simple. x1 is a rectangle, x2 is a rectangle too. You can determine the Fourier transform of x1 and x2 easily. Okay, and the Fourier transform of the final result equal to the sum of x1 and x2. Okay, now from the problem, we can express the Fourier transform pair of the signal x1 and x2 by here. Okay, you can use the table or you can determine the Fourier transform of x1 by hand. Okay, x1 is a rectangle. Okay, the Fourier transform of them equal to 10 sin 10 omega. The Fourier transform of the x2 is the cross similarly the form of the x1 only is the the widings of the rectangles. The y of the rectangle is different. Okay, therefore it's still the same function, but the shape of them is different too. Okay, the Fourier by using the linearity property, we can determine the Fourier transform of xt by adding between x1 and x2. Okay, therefore the Fourier transform equal to the adding of them. Okay, the sum of them too. Okay, or the next one is the time shifting. Okay, for the time shifting, if you know the Fourier transform of xt, okay, is x omega, j omega. The Fourier, what about this transform? This is a time shifting. Okay, if you shifting xt by t naught, instead you must recompute the Fourier transform again. No, you can use the previous result and you multiply them by a symbol e minus j omega t naught. Depend on how much, okay, how the longer you shifting them. If t naught equal to 10, this thing is 10. Okay, j omega 10. If t naught, okay, is 100, okay, this thing is j omega 100 too. Okay, due to the time shifting property, the Fourier transform magnitudes does not change. Okay, you can see that if you consider only the magnitudes of them, okay, because the complex exponential, okay, the magnitudes of the complex exponential is 1. Okay, from the time shifting property, the Fourier transform phase of the signal is changed only. For the magnitudes, it don't change. Now, to make you more understand, I will provide about some example for this. You can see that this signal is not the original rectangle. Okay, the original rectangle is GT. Okay, but this signal is maybe shifting a little bit in the right hand. Okay, therefore, instead we compute xt by use the real integration at all steps. No, you can take advantage from the result of the Fourier transform of the rectangle. The Fourier transform of the rectangle gives you the sinc function. Okay, but in this case, you require shifting a little bit one. Okay, you shift by phi. Okay, shift by phi. Therefore, if you shift by phi, okay, here t naught equal to phi. Okay, t naught equal to phi. Therefore, you must multiply with e minus j omega phi 2. Okay, the same thing. Every term is the same as the gt. Okay, except you multiply them by e power minus j omega t naught, or t naught equal to phi in this case. Okay, this is about some application of the time shifting property. Okay, now in the reverse process, okay, if you shifting in the frequency instead, okay, if every omega you shift by omega naught, okay, yes, you multiply the time function by the complex exponential ej omega naught t, okay, and the omega naught equal to the frequency that you shifting. Okay, okay, using the Fourier transform property, determine the Fourier transform of the multiplication between x1 and x2 is here. If x1 equal to the cos function, x2 equal to 5 cos function. Okay, x1 equal to 2 cos. Okay, 200 pi t. x2 equal to 5 cos thousands pi t. Okay, when you multiply them, you can see that when you multiply them, you know that, okay, you would like to determine the Fourier transform of the multiplications result. If you multiply them already, okay, the way to find them is not easy. But here, before we multiply them, we can extract cos by use the Euler relations, change them to be the complex exponential form. Okay, and by this property, you know that, okay, if you multiply, okay, the frequency, the complex exponential in time, okay, it equal to the shifting property in the frequency domain, right? Yeah. Yeah, this thing you can do forwards or the backward, right? Multiply with the complex exponential in time, okay, equal to the shiftings, okay, in the frequency domain. In this case, you're shifting by 1000. Okay, now, okay, in this case, you can see that shifting by here to graph, and the Fourier transform of the cos give you the data function, okay, two data function at that frequency, and the frequency of the cos is 200, okay, but omega naught equal to 1000 for this case, okay, you shifting in the left hand and the right hand of that impulse, okay, by minus 1000 and plus 1000. The second term is the same, okay, therefore in the final answers, okay, it becomes the four impulse that shiftings in, okay, left hand and the right hand of the, okay, of the thousands frequencies, okay. Okay, now in the overall point of view, what happened? X1 is here, okay, X1 is this Fourier transform. The X1 is a cos function, give you two impulse function. X2 is the same, but the frequency of them is higher at 1005, okay. It seems to be you convolve between them, okay. Impulse convolve with anything, give you impulse, okay, give you impulse. This is, okay, the green, okay, the green, okay, convolve with two red, give you here and here, okay, and the blue will be here and here. You can see that this is the result of them, okay. The green part is here, the blue part is the blue shading term, okay. Next one is the conjugation and the conjugate symmetry, okay. If xt have the Fourier transform xj omega, and the Fourier transform of them equal to here, what about this? This is a conjugate. In general, xt is a real number. Therefore, we don't have the problem for each conjugate. But sometimes xt can be a complex number. If it's complex number, such as 1 plus 5j, this, what about the Fourier transform of its conjugate? If 1 plus 5j is conjugate equal to 1 minus 5j instead, okay? The Fourier transform of them equal to the frequency reversals, okay, and is conjugate in the final step, okay. Or if xt is real, okay, it's very easy, okay. The Fourier transform of them equal to x minus j omega, or is conjugate of x, okay. If x is a real and the even, okay, if x is a real and the even, sorry. If x is a real and the even, the Fourier transform of them is a real and the even too. But if x is a real and the odd, the Fourier transform of them is only imaginary numbers and only odd. Okay. Next one is time scaling. Okay. Time scaling is here. Okay. If you know the Fourier transform of xt, okay, you would like to find is time scaling of them. Okay. Is time scaling is mean you scale by the frequency by a. Every omega you divide them by a, scale by a, and in the overall magnitudes you normalize by absolute a. If the Fourier transform of the signal xt shown in this figure is here. Okay. If the Fourier transform of x, you can see that the Fourier transform of the rectangle give you the sinc function. Okay. But the Fourier transform of another rectangle, it still gives you the sinc function. But in this case, instead we reintegrate every step again. No, we can take advantage from the previous time scaling. In this case, G is the time scaling of xt by half, right? By half. Therefore, okay, from the time scaling property, you scale by, okay, A, in this case, A equal to 2, you scale by half, okay? If A equal to 2, okay, GT is you scale by 2, okay? Divide every omega by 2 and divide in the overall magnitudes by 2, okay? You can see that you not necessary to recompute the Fourier transform of them. You only know how to divide them by take advantage of this property, okay? Divide every omega by A and divide the overall magnitudes by absolute A. Okay. Next one. Okay. If you you can see that. Therefore, you can see that if you scale the time frequencies, okay, if you compress the signal in time, it seems you expand in the frequencies, okay, in the reward process. If you can see that if you have the GT at the original, if you expand them, okay, in the time, the frequency you compress them, okay, you compress them. Next one is the time differentiation. For the time differentiation, you differentiate xt one time. You multiply by j omega. If you differentiate them 2 times, okay, you multiply by j omega square. Okay. If you differentiate them n time, you multiply by j omega power n. Okay. Next one is the time integration. For the time integration, if you integrate xt one time, you divide by j omega. You can see that the integration and the differentiation is a reverse. If you differentiate them one time, multiply by j omega. If you integrate them one time, you divide them by j omega instead. Okay. And the next one is the frequency differentiation. If you differentiate in the frequency, okay, you differentiate is Fourier transform of xt, okay, by respect to omega, it equal to you multiply by minus jt one time. If you differentiate them 2 times, okay, you multiply by minus jt power 2 and so on, okay. The last one is the duality, okay. If you know xt have the Fourier transform of xj omega, okay, if you know xt in the same shape of the is Fourier transform of the previous step, okay, its inverse Fourier transform of them will be the close similarly form of the xt, but it have something a little bit different. The first one is instead you get xt, no, you get x minus omega, okay, and normalize them by 2 parts. Okay, in order to give you more understand, we will show you in here. If we have xt, the Fourier transform of xt is give you the sinc function. But in this case, you can see that if you know the Fourier transform of this signal, okay, of this signal, okay, if the Fourier transform of this signal is a rectangle, it means the signal in time will be the sinc function instead. Yeah, to show you here, you can see that if you have this rectangle, if this shape, the Fourier transform of the rectangle, therefore the duality, the xt in time should be the sinc function. Okay, but must correspond with the y and the height of this g omega. Yeah, you can see that. The last one is called the Parseval relation. The Parseval relation frequently used in the telecom engineering for determine or estimate the power of the signal that you cannot know in, or you cannot write them in the full or complete mathematical form. We know we would like to know them only the power of them and the signal of them is stable or not. Okay. If you know the Fourier transform of xt is x omega, therefore if you take square and integrate them, okay, it means you would like to find the total power or energies of them in time equal to you take square in the frequency domain and integrate them in all range too. It means the power in time must equal to the power in the frequencies. For the Parseval relations equation, the left-hand side term of the equation is the total energies of the signal xt, and from the Parseval relations equation, the total energies of the signal may be determined by computing the energies in time domain or computing the energy in the frequency domain. We call them the energy density spectrum. Okay, this for example. Okay, you can see that if you know xt, x omega is here. Okay, the questions would like to find, or you would like to integrate xt square. Okay, you have two ways to console now. The first one, you determine the inverse Fourier transform to get xt first, right? Require one integration step. And the next one, after you get xt, substitute them in here and require another integration. Okay, to determine in the final step. But if you apply the Parseval relation, you not necessarily to indicate anything. Okay, the Parseval relation so that okay, if you have xt and it have the Fourier transform about that, you would like to find okay xt square. Xt square in this case is equal to x omega square. X omega square is mean you take square in the magnitude point of view. Okay, equal to square root pi square give you pi. Okay, and so on. After that you integrate them. The integration, it have the meaning that you would like to find the area under this graph. The area under this graph is the green shading that I show it to you. Okay, the green shading is comprised by the three rectangle form. Okay, the first rectangle is the first block it here. Okay, between okay 0.5 and pi. Multiply them. Okay, you get the first block. Okay, pi by 2. This pi by 2, and the middle one equal to pi by 4 multiplied by 1. Therefore, the Fourier, the xt square, the integrate xt square equal to 5 by 8. You can see that if you can know how to apply this equation on this step, okay, you can save. Instead, you must integrate two main steps directly. No, you can find the result of them by integrate them a little bit one. Yeah, it's your turn. Do it and submit them in 20 minutes. Can you hear me?
Yes.
Okay, capture it. Okay, it's already in the end of this chapter. Okay, the question at the end of this chapter. Okay, can I stop showing? Okay, it's time to check your attendance. Okay, show your face now. Open the camera to see your face.ง่วง ว่าไงนัชชยาแมทแลบฟิกได้ยังฟิกแมทแลบได้ยัง
ได้แล้วค่ะอาจารย์
ชนิกาเป็นไงบ้างทำอีเมลเสร็จยังเป็นไงอาจารย์ทุกคนให้การบ้านเต็มไปหมดเลยไหมก็เขาคิดว่าเราอยู่บ้านไงมีเวลาว่างเยอะเขาก็เลยให้การบ้านเยอะไปด้วยหรือมาโรงเรียนเนี่ยการบ้านน้อยกว่า
น่าจะพอกันนะคะ
โอ้ยไม่ต้องคิดมากหรอกทำไปเถอะฟาร์มคลิปเข้าไปเดี๋ยวก็โตเองถ้าไม่โดนคลิปตกตายก่อนนะพัทรนันท์เป็นไงบ้างดูหน้าตาเหมือนยังไม่ค่อยตื่น ส่วนชนนิกานี่ผมเป็นเอกลักษณ์มากเลยถ้านี่มันเริ่มจางๆแล้วมันโกกถ้าผมมันเต็มหัวแล้วมันทำย้อมใส่เจลผมตั้งๆด้วยจะนึกว่าเป็นชาวไซย่านะเนี่ยนะช่วงนี้ชาวไซย่าเขาเป็นซูเปอร์ไซย่าเห็นแวบๆในหนังสีน้ำเงินแล้วเมื่อก่อนมันยังเป็นสีทองอย่างนี้มีสีน้ำเงินด้วยรัตพลเป็นไงบ้างนะจะหลับยัง
ยังค่ะทำอยู่
เป็นไงคะแนนมิดเทอมออกมาเป็นไงกันบ้างฮะได้เยอะกว่าที่คิดใช่ไหมลดราคาครึ่งหนึ่งไหมหาร2หมดเลยทั้งห้องเงียบไปไว้หารใช่ไหม
ไม่ครับ
เหรอเอาตั้งใจกันนะไฟนอลหนูไม่ได้เจอกันแล้วนะ If you already finished, okay, you can post in the meeting chat, okay, and I will provide you, okay, solution.
อาจารย์ครับยังไม่ดูคะแนนเลยตัวหนึ่งนะครับอาจารย์ลืมเปิดไมค์อาจารย์ลืมเปิดไมค์
เอ้ามันอยู่ในนั้นไม่ใช่เหรออยู่ใน meeting chat เนี่ยยังไม่ได้ดูอีกเหรอ
ไม่ดูเลยครับเดี๋ยว
ไปดาวน์โหลดในไฟล์เก่าๆมาดิ
เดี๋ยวไปแอบดูหนึ่งครับ
มันยังค้างอยู่ในระบบไม่ใช่เหรอวะไม่เป็นไรเดี๋ยวผมแก้ให้ใหม่เหลือสัก2แล้วกันจาก30
ถึงหรือเปล่าดีกว่า ถึง2หรือเปล่า
ทำไมมันอนาถอย่างนั้นเลยเหรอไอเดียอะไรหนูเราน่าจะไอเดียแก่ๆนะ
อาจารย์เดี๋ยวผมแอบดูเองก็ได้ครับผมเห็นแล้วเป็นหนึ่งอาจารย์โอเคครับเห็นแล้วครับ
ก็ได้ตั้ง17.5นี่
อาจารย์จำได้ไง
โอ้ผมเปิดไฟล์เร็วจะตายคิกก็เปิดแล้วอะไรกันอะไรลงตั้งหลายรอบมันต้องได้27.5แล้วเว้ยไม่ได้17.5นี่นะโอ้ยเดี๋ยวโดน
มีเทอมกดเยอะไฟนอลก็ไม่ลุ้นดิอาจารย์
ไม่รู้ได้เลยเดี๋ยวให้ลุ้นระทึกกัน
อาจารย์ผมล้อเล่นอาจารย์ผมล้อเล่นอาจารย์
ทำไมไปพลาดอะไรมาเรา
ไม่แน่ใจ
ฟูเรียหรือ convolution
น่าจะ convolution แหละครับ
ถ้าตายก็ตายอยู่2อันนี้แหละตั้งใจทำให้หนู
ครับผม
จะได้ผ่านๆนะเพราะส่วนใหญ่โควิดมาก็ด้วยสถานการณ์ด้วยการเรียนการสอนที่ไม่สมบูรณ์พร้อมนะก็จะนะมันก็ไม่ได้ออกข้อสอบแบบเต็มเม็ดเต็มหน่วยเท่าไหร่ทำโจทย์ซะไปแล้วเดี๋ยวส่งมาใน meeting chat จะได้ตรวจให้ รัตพันธ์รัตพลโทษทีรัตพลส่งมาใช่แต่ผิดนะ เช็คดูดีๆมันอินทิเกรตจากไหนถึงไหนมันไม่ได้อยู่ตรงกลางนะ ได้ยินไหมเอ่ย
ได้ยินค่ะ
เช็คดูดีๆนะ เช็คดูดีๆดีแล้วที่ส่งเงี้ยจะได้รู้ว่าไม่เข้าใจตรงไหน รีบแก้ซะก่อนนะไฟนอลจะได้ทำได้
Teacher, can I do this?
If you finish this question, you can do the next one. Okay, the next question from the the problem at the end of this chapter. Okay, and I will maybe in another 10 minutes I will provide you solution for this. Okay, and provide you in the next one. Okay. I think it's okay. Can you hear me? I think the first question is already, I think almost finished them, okay? The key when you see about okay, this rectangle, you can see that this rectangle, you can separate them into graph, right? Here and here. But the graph is not in the middle, okay? Therefore, you require to shifting them, okay? If you require to shifting them, it means you use two property. One, you use the linear to extract the complex function into the simple function. And the second one, you use the shifting property to make them in the classical rectangle form. Okay, the rectangle is here, and this will be require the shifting by 2.5 seconds. Okay, you shifting by 2.5 seconds. Therefore, by using the time shifting property, required to shifting by 2.5. Okay, the rectangle give you the sinc function. Shift by 2.5 is mean you multiply by e minus t naught. T naught equal to 2.5. And x2 is the same manner. Okay. The result, by using the linearity property, we can determine the Fourier transform of the original signal xt by summing x1 and x2 in the rectangle form, but shifting by 2.5 give you the sinc function. Two rectangle give you two sinc function at different shape. Okay. And shifting by here 2.5. And the next one is about here, right? About the duality and the other. We give you do it small, and I will provide you solution soon.
อาจารย์คะอาจารย์ให้ทำอะไรต่อนะคะ
ก็ทำข้อต่อไปในท้ายบทอ่ะฮัลโหล
โอเคค่ะ
ได้ยินไหม
ค่ะ
ทำข้อ
ค่ะ
ต่อไปในท้ายบทเห็นไหม
ค่ะ ค่ะ
เดี๋ยวจะเฉลยให้ทีละข้อทยอยทำไปแล้วส่งไปผมก็จะเฉลยให้ดูนะ ถ้าเกิดว่างก็จะได้ไปทำเองจะได้มั่นใจ แต่ว่าถ้าอย่างเงี้ยผมก็จะช่วยดูให้ The second question is finished. No. This question right ข้อนี้ใช่ไหมทำกันเสร็จยังยังอยู่กันหรือเปล่าเนี่ย Okay, I will give you another 5 minutes, okay, to do that, okay, and I will provide your solution soon.
โอเคจ้ะ Oh, I will provide your solution for the second one, okay, to give you clear, okay, listen up and see them clearly, okay, what happened to the second question, okay. This question is xt is here e minus absolute tau, okay. If we assume that, okay, if we assume that this Fourier transform of them equal to here is asked you to determine function gt that in close similarly to this form. You must use the duality properties, okay? From the duality property from this problem, we can express the Fourier transform pair of the signal xt. Okay, xt is here Fourier transform of xt equal to x omega equal to 2 divided by 1 plus omega square. Okay, from the duality property, you know that if xt is here, okay, xt is 1 by t square, should be in this form, but you must multiply by 2 pi, okay, and minus omega. Therefore, we can determine the Fourier transform of them. Okay, you can see that this form is close similarly to this form. Okay, therefore the duality is the same. Okay, only one thing different. Okay, is here multiply by change omega by minus omega and multiply them by 2 pi. Only that. Okay, and the next one, this all three. Okay, 3 by 3. The question 3.3. Okay, do it, and the next time I will provide you solution to know how to solve them. Okay, clear? Okay, now the assignments today, okay, do the question 3.3, okay, and the next time I will provide you solution, okay, how to solve them. Each of them is use different property for each case, okay. The first one, you can see that 4t is mean you may be used require the time scaling or time shifting, or both of them, differentiation in time, reversal, or multiply by the exponential. That may be required you use, okay, the frequency shifting in this one, okay. Okay, any question?
No.
Okay, see you next time, okay. 3.3, do by yourself and show me in the next time, and I provide you solution, okay. Maybe 5 minutes, the first 5 minutes of the lecture, we will give you, provide the solution, okay. Good luck, see you next time.
Thank you, John.
You're welcome.
สวัสดีครับ
สวัสดีครับ
thank you ค่ะอาจารย์สวัสดีค่ะ
ขอบคุณครับ
สวัสดีครับ